Welcome to Mathematics and Statistics, Mastering with PYK. We'll be continuing with matrices. In this part, we'll be covering elementary transformations, inverse matrices, cofactors, and other concepts. So let's understand what are determinants and how do we find the determinants. We know that the matrices are always denoted by the square brackets and determinants are denoted by the parallel lines. So a determinant is a scalar value. This means it will have a value. It can be negative, it can be positive, which is calculated from the elements of the square matrix. So we know that a determinant can be found only when there is a square matrix. So see, this is an example. Say a matrix A, so denoted by the square brackets, right? A, B, C, D. While determinant A is denoted by the parallel lines, right? So how do we identify a determinant or calculate a determinant? So determinant A, we will have a square matrix, and for calculation, what we do is that we cross multiply. We take the elements which are cross and subtract it from the multiplication or a dot product of the cross elements. So here it is AD, right? AD less B multiplied by C, and this is of the order 2 by 2. If we have a determinant with 3 cross 3, so how do we proceed? In this case, when we are sitting at A or I am at the position A, we will ignore the column of the A and the row where A belongs, and we will be going with the determinant of the remaining 4 elements, right? So how do we do it? We have A, right? So it will be A multiplied by determinant. So this will become a determinant, right? This will become a determinant. So it will be A multiply in bracket E dot I less F dot H. Similarly, at the position B, it will be B and the determinant of D and I less F and G. Right? Similarly, for C position, we have C multiplied by the determinant of these 4 elements, that is D cross H less E cross G. Right? So we have determinant calculated as this. Do remember these signages, right? So what happens here? These signs are alternate positive and alternate negative, right? So it is plus. So it is plus. Let's take up a simple example of a 2 cross 2 matrix. So here it is A, B, C, D. So the determinant is denoted by the parallel lines. It is of order 2 cross 2. So it is very simple. It is A multiplied by D less B multiplied by C. So here the answer would be 2 multiplied by 3 less 4 multiplied by minus 2. So this minus 2 becomes an addition signature sign. We have 6 plus 8, which comes out to be 14. Right? So determinant of the given matrix is 14. For the second question, we have a matrix of the order 3 cross 3. Right? So for 3 cross 3, what will be done? When we are at the position 2, we'll ignore the rows and columns of the position 2. The remaining, we'll be finding the determinant and multiplying it by 2, right? So for the first row, it is 2 multiplied by the determinant 2 multiplied by 2 less minus 1 multiplied by minus 1, right? Similarly, when we are sitting at position of minus 1, right? This signature will be minus because we had the alternate plus minus plus, right? So when we are here, we will be subtracting the second determinant and the third determinant or the third value gets added. So we come to the value which is 4. Now what is the inverse of a matrix? Right? We have learned about the transpose of a matrix. Now we'll be understanding the inverse of a matrix. Now inverse of a matrix means if there are two matrices A dot B and B dot A, and if the product or the resultant is I, that is a unitary matrix, and the matrix is also a square matrix, then the B is called the inverse of matrix A. It is denoted by A raised to minus 1. So, A multiplied by A inverse is same as A inverse dot A, which is equal to an identity matrix of the same order. If A inverse exists, so now we are going for the further concepts where we are saying if the inverse of the matrix exists, then the determinant cannot be 0, right? And it is called as non-singular matrix, right? And the value which we get for the A inverse, it will be always a unique matrix. This means the answer or the resultant to the A inverse is also unique or same for all the members, right? So let's revise. A dot A inverse will be same as A inverse dot A, and the resultant is the identity matrix. If A inverse exists, when we say if A inverse exists, meaning there is a possibility that the A inverse will not exist, meaning the determinant of A will be 0, right? This will be 0 if it does not exist. So this means there is a possibility of A inverse not existing, right? Now here, this is a matrix of an order 2 by 2, and we have seen this, we have solved previously. So we found that the determinant is 14. It is not equal to 0. This means from here we get that the A inverse exists and it is a non-singular matrix. The resultant would be that the A inverse would be a unique matrix. So let's understand few more examples. We have been given a matrix which is 2, 4, minus 1, 7. We have to find the cofactor of the matrix A. Now what is a cofactor? So cofactor of a matrix Aij is given by the formula minus 1 to the power I and j of that row and column, and the determinant of Mij, which is also written simply as without determinant also, that is Mij, right? So let's find what is M. M is the minus. M is denoted by minus for minus. So here the cofactors would be, how do we find the minus? This is a very simple matrix because this is 2 cross 2. What we do is, for the M11 position, we will be ignoring the column and the row. So we are left with 7 only. The determinant is not possible because we need minimum 4 elements. So M11 becomes 7, right? Similarly, when we have to find for M22, this means M22 is here. So we'll be ignoring this and we'll be ignoring this. We are left with 2. So the value here would be 2. Similarly for the other elements, this means when we are at M12, we'll be ignoring this column and the said row and we'll be left with minus 1. But there is an additional parameter of minus, right? So instead of remembering this, we can always remember that the determinant is found with a sign change. So this is how the sign work. So this is alternate plus minus sign. So here it is plus, so no change. Here it was minus 1. So the sign got changed, minus and minus, so it became plus. Here it is negative sign, right? So it has got a negative, and here it is a positive sign, so we got plus 2. So these are the cofactors of A, right? So these are the cofactors of A. Now adjoint of A or the adjugate of a matrix A is given by the transpose of the matrix which is obtained after finding the cofactors. So this is the transpose of not the original matrix but the transpose of the cofactor matrix, right? So adjugate or adjoint of A is nothing but the transpose of the cofactor matrix. So we have a cofactor. So when we transpose, what does a transpose means? The row interchange to column and column interchange to row, right? Understand few more examples. So we have a matrix given by 2, minus 2, 4 and 3. So the matrix order is 2 cross 2, right? So the matrix order is 2 cross 2. We have to find if the matrix B is invertible and also find the adjoint of B and B inverse. So we know how do we find the determinant? We would be cross multiplying, right? And we'll be getting the scalar value. So here the determinant is 2 multiplied by 3 less 4 multiplied by minus 2, that comes out to be 6 plus 8, that is 40. Now the determinant is not equal to 0. This means that the inverse exists. So we have that the matrix here B is a non-singular matrix and the B inverse exists, right? It will be always a unique matrix. Now cofactors of B. How do we find the cofactors of B? We'll be finding with the formula Mij multiplied by minus 1 to the power I plus j. So for this we will remember the signages, that will be plus, minus and minus plus, right? So here it's very easy. We'll be for M11 we'll be ignoring the column and the row. We are left with 3. This position is positive, so here 3 is positive, right? For the M12, for M12 we will be ignoring this column and this row. We are left with 4, so 4 goes here, but then the sign which we have to not ignore, the sign would be negative, so this element gets a negative sign, right? So this is the way we get cofactors of B, which is 3, minus 4, 2 and minus 2. Now adjoint of a matrix. Adjoint of the matrix is obtained by transpose of the cofactor matrix. This means the matrix which we have got as this will transpose. So how do we transpose? Transpose is simple. Interchange the column to rows and rows to column. So when we say B inverse is given by, this is the new formula which we have to remember. B inverse is given by 1 upon determinant of B multiplied by adjoint of B. So we got the adjoint of B. We have the determinant, that is 14. So the B inverse is minus, B inverse is denoted by V raised to power minus 1, which is 1 upon 14 into the adjoint or the adjunct matrix B, which is nothing but the transpose of the cofactor matrix, right? We'll go cofactor matrix, and the cofactors are obtained by the minus 1 raised to the power ij, right? I plus j, and multiplied by the minus calculated as a determinant of the matrix, right? So how do we do it? Now let's understand the algorithm. So once algorithm is clear, it will be very easy to calculate, right? So how do we do it? First, check if the determinant exists. If determinant is 0, this means the A inverse does not exist or it is a singular matrix. If it is not equal to 0, then the matrix is called a non-singular matrix. A inverse exists and it is a unique solution. We have to find then the cofactors of the matrix, which is given by minus y 1 raised to the power ij multiplied by the minors. Adjoint of the matrix is nothing but the transpose of the cofactor of the matrix. A inverse is obtained by 1 upon determinant of the A or the determinant of the matrix multiplied by the adjoint matrix, right? So these 4 steps you have to remember to find the A inverse. Now let's understand. Again, determinant A for 2 cross 2 matrix is very simple. You cross multiply and subtract the dot product of the cross elements, right? So it is A dot D less B dot C for 2 cross 2 matrix. So cofactor of a matrix is also called as a matrix of minors with sign change. Why? Because we use alternate plus minus sign or minus 1 raised to the power I plus j, right? So this is how we find the cofactors. Adjoint of A is nothing but the transpose of the cofactor matrix, and A inverse is 1 upon determinant of A, that is the scalar value multiplied by adjoint matrix A, right? So adjoint of the matrix is equal to transpose of the cofactor of matrix, which is also called as a transpose of matrix of minors with sign change, right? Now what if we have 3 elements? So our matrix is now 3 cross 3. How do we do it? Right? So for 3 cross 3, how do we find the M, that is the minors? What we do is that if we have to find the minor M11, right, we'll be ignoring the rows and the columns and we are left with this determinant. So solving this determinant gives us M11. Similarly, when we are doing it for B, we'll be crossing, ignoring the column and the row and finding the determinant value of the remaining elements. Similarly for C, and we'll continue for all the elements. So we'll be left with the final matrix, which is with the sign change. So this is plus, minus, plus. So this will be minus. Then this will be alternate plus, minus. So remember this to find the cofactor. This is how we find the cofactors of a matrix with 3 cross 3 elements. Now let's revise the concepts. If A is a non-singular, now it can be other way parameters given to you. So if A is non-singular, this means A inverse exists. This means the determinant is not equal to 0. It is also called as invertible matrix, right? Inverse of a matrix and its inverse is same as the original matrix. Remember the concept of transpose. It works on the similar way. So transpose of a matrix and its transpose, right? We will be getting the original matrix, right? And when a multiplication or a dot product of a matrix with its inverse, we will be getting an identity matrix of the same order. If a matrix is a transpose and we have to take the inverse, it is same as inverse of the matrix and then having its transpose. If A and B are non-singular matrix, this means the A inverse exists and B inverse exists, then the dot product is also non-singular. This means determinant of this dot product AB would be not equal to 0. This means the value would be some scalar value, negative or positive, right? Similarly, if we have AB inverse, this means a multiplication matrix inverse, which will be same as B inverse dot A inverse or A inverse dot B inverse, right? So it can be other way around also. So it can be A inverse. So the resultant matrix does not change, right? So these are few properties which you should remember. Next part, keep practicing. The elementary transformation, we'll be taking it in the next series, right? You can't build a great building on a weak foundation. So practice your concepts, be clear, gain confidence. Bye-bye. See you.